Hi guys, welcome to the next section, Cloud Data Centers, the New Reality. In this section, we will start with Amazon Web Services, EC2, S3, ECR, and ECS. We will also see Google Cloud Platform. Now, we move on to the first video of this section that deals with Amazon Web Services, EC2 and S3. In this video, we're going to take a look at launching an instance for EC2. We will also see relational database service and networking in AWS and EC2. Amazon is by far the biggest online retailer with an almost worldwide presence. It makes sense that a big company such as Amazon needs a lot of processing power, is reliable, and is able to adapt to the necessities of the business quickly. Initially, the cloud services were an internal solution to satisfy the high availability needs of the business, as well as have the capacity to grow in a uniform way. This created a lot of expertise within the company in building a top-notch infrastructure as a service that at some point they realized could be sold to customers. There are two services, EC2 and S3. EC2 allows you to create virtual machines on the cloud with an API that was manipulated through a command line interface, as well as a web interface that would act as a monitor of your resources. S3 was a key value storage that allowed you to store immense sets of data at a very low price, manipulated through the command line interface as well. It really was a revolution. It was a complete paradigm shift. Now you could ask for more resources as you need. Now we move to EC2, that is one of the computing service. The first element that a cloud system has to provide to the users is computing power. EC2 stands for Elastic Compute Cloud. It allows you to create machines on the cloud with a few clicks. This is what the EC2 interface looks like. It provides the user with different sizes of machines and is available across the cloud. This means that the user can spin up machines in different parts of the globe for high availability and latency purposes, enabling the engineers of your company to build multi-zone applications without coordinating teams across the globe. They also provide different types of instances optimized for different tasks so that the users can tailor the infrastructure to their needs. Let's take a look at an example of how to launch an instance. The first thing we need to do is go to the AWS EC2 interface. Now we click on the Launch Instance button, which will bring you to this screen. This is where you can choose the image to run. As you can see, the image is the operating system that will run on top of the EC2 instance. In Amazon jargon, the image is called Amazon Machine Image, and you can create your own ones and save them for later usage, allowing you to ship pre-built software. For now, we choose Ubuntu Server 16.04 by clicking on Select. The next screen is about the size of the image. AWS offers quite a big variety of sizes and types of images. This parameter drastically affects the performance of the application regarding the network, memory, and CPU performance, as well as the I/O of the machine. As you can see, there is an instance for every necessity that the user can have. For now, we're going to choose a small instance first because we're just testing AWS, and second because AWS has a free tier, which enables you to use the T2.micro instances for up to 1 year without any charge. Now we have two options. First one is click on Review and Launch, and the second one is Configure Instance Details. In this case, we're going to click on Review and Launch. But by clicking on Configure Instance Details, we can configure several elements of the instance, such as networking, storage, and so on. Now, we click on Review and Launch. The review screen shows up. Next, we click on Launch, and you should get presented with something similar to this. We will assign a name to the key pair name first. After that, we will click on the Download Key Pair button, which will download a PEM file that we will use later on to access via SSH to the instance. Once the key pair is specified, we click on Launch Instance. After a few checks, the image will be ready for installing the required software. This usually takes a couple of minutes. This is the bare minimum needed to create a running instance in AWS. Now we will move to Relational Database Service. There is another service that allows you to administer high availability databases across regions. This service is called RDS, and it stands for Relational Database Service. One of the big headaches with relational databases is the high availability configuration. Master-master configuration is something that is usually expensive and out of reach of small companies. AWS has raised the bar with RDS, offering multi-region high availability databases with a few clicks. Now, we move on to networking in AWS and EC2. AWS provides fine-grained control at the networking level. As with any physical data center, you can define your own networks, but AWS has a higher level abstraction concept that is the Virtual Private Cloud. Amazon Virtual Private Cloud is a segment of the AWS cloud that allows to group and segregate the resources in subnetworks to organize and plan your infrastructure, matching your requirements. It also allows you to create a VPN between AWS and your physical data center to extend the latter one, adding more resources from AWS. Also, when you create a resource in EC2, you have the possibility of creating the resource in your custom-defined subnet within your VPC. Let's explain how AWS works regarding the geographical distribution of resources. AWS provides you with different data centers in different regions, such as Europe, Asia, and the US. As an example, let's take EU West, which has 3 different availability zones. The concept of region in AWS is basically a geographical area where the AWS data center lives. It enables us to build global-scale applications that serve the traffic from the closest data center in order to improve latency. Another very good reason for geographical distribution is the data protection laws in several countries. By being able to choose where our data lives, we can enforce the compliance with the laws. Inside of these geographical regions, sometimes we can find availability zones. One availability zone is basically a physically separated data center that ensures the high availability of our system. As in the case of a catastrophe in one of the data centers, we can always fall back on the other availability zones. Let's see how the regions and availability zones look. Now that we understand how AWS works from the geographical perspective, let's dig deeper into what a VPC is in terms of regions and availability zones. A VPC is a logically separated segment of the AWS cloud that is private to the user. It can hold resources and spans across all the availability regions in an AWS zone. We can define different subnets and define which machines are reachable from the Internet. AWS allows you to create routing tables, Internet gateways, and NAT gateways among other common networking resources that enable the user to build anything that they can build in a physical data center. If you really want to dive deep into the networking side of AWS, you can find more data and examples at this link. AWS also provides a very powerful element, elastic load balancing. An ELB is a modern version of the classic hardware load balancer. It enables us to health check resources and only get the healthy ones into the pool. Also, AWS comes in 2 flavors. The first one is Classic Load Balancer, and the other one is Application Load Balancer. An Application Load Balancer distributes the traffic depending on health checks and does not understand the data being transmitted, whereas the Application Load Balancer can route the traffic based on advanced policies dependent on the information of the request. ELBs can also handle the full HTTPS flow so that we can carry the SSL termination in the load balancer and allow our applications to offload the encryption or decryption to them. One important thing when building applications is the storage of the data. By default, when we launch a machine in EC2, there are 2 types of storage that can be associated with the machine in the root volume in order to run the operating system. The first type of storage is instance storage-backed images, and the second type is Amazon Elastic Block Store Storage backed images. The first one, Instance storage-backed images relies on the storage associated with the image to mount and run the root volume. It means that the data stored in the image will be lost once the machine is terminated. The second type of instances are the ones backed by EBS. Elastic Block Store is the name that AWS gives to its storage capabilities. Let's move to Amazon S3. Amazon Simple Storage Service is, as described by its name, a simple way of storing a large amount of data on the cloud at a very low cost with a nice set of features. Amazon S3 is practically a key value storage that enables us to identify data with a key. S3 is prepared to store from tiny to very large objects with very low response times and that are accessible anywhere. It is a feature that has the concept of regions, but S3 does not understand availability zones. The S3 service itself manages to get objects stored on different devices, so you don't need to worry about it. Another advantage of S3 is that AWS provides a REST API to access objects in a very simple way, which makes it fairly easy to use it as storage for the modern web. Another interesting feature of S3 is the possibility of integrating it with Amazon Key Management System, so all our objects in S3 are encrypted by a key stored in KMS that can be transparently rotated periodically. In this video, we've looked at Amazon Web Services, EC2 and S3.